Okay, today we're going to be looking at forming differential equations from worded questions, not necessarily solving them, but the solving might come in the examples later on, and it will come in some of the other work we see. But it's how to turn the written text into differential equation shorthand. So example 1 says, after a major advertising campaign, an engineering company finds that its profits are increasing at a rate proportional to the square root of the profits at any given time. Form a differential equation to model the situation. Well, since they haven't specified, it's probably a good idea to say let P equal profits, so we know what we're using as our variable, and then rate of increase. Unless it says otherwise, a rate of increase is d by dt, so dp by dt in this case. It's an increase. Be aware if it says decrease or something along those lines, there'll be a minus there. And because it says it's a rate proportional to the square root, we turn the proportionality into an equation by writing equals k and then times the square root of p. And that's it. That's turning that sentence into shorthand. So it says that the rate of increase of the profits is proportional to the square root of the profit. Okay, and that's all there is to it. Second one says the rate at which a sunflower increases its height is proportional to the natural log of the difference between its final height and the height h at a particular time. So they've specified what all the letters stand for. The variable is going to be h, little h that is. We've got a constant final height, big H, and it's about to find the difference. So find the difference equation to model this one. So we're going to say that d little h by dt, that's the rate of increase, equals k, and then the difference between its final height and little height, so it's big H minus little h. And that's it. So it's the rate of increase of the height is proportional to the difference between the final height and the initial height. So it's just taking the sentence and turning it to shorthand. Now, third example's got much more going on with it. It says, at time t is 0, there are 8,000 fish in a lake. So I've said t is 0, n equals 8,000. At time t days, the birth rate of fish is equal to 1/50th of the number n of fish present, and also fish are taken out of the lake at a rate of 100 per day. There's a show of that for a differential equation, then we have to solve it and then find the time for n to increase from 8,000 to 11,000. Okay, so let's have a look at it then. I've done a little sketch of my lake. It's a rectangle. I'm not much of an artist, but it's worth doing this because all these rate of change ones, there's often something going in and something going out, like water in a tank. You could have a leak, whatever, and there's a rate coming in and a rate going out. So I've got as a going in n over 50, that's 1/50th of n, and a constant rate being taken out of 100 per day. So that I can say that dn over dt is now, because it's not a proportionality, it's just that's what's going in, that's what's coming out. It's just one minus the other. I'm making an assumption that what's going in is more than what's coming out, so I can say it's n over 50 minus 100, and then times by 50 to get 50 dn by dt equals n minus 5,000. That was the show of that. Okay, so in that case there, I can then use that to go on and solve it. So I've got my setup. I'm then going to go on and do what we looked at in the past about separating variables and taking it from there and going on and solving the thing. Because I'm going to be using a lot more working, I might rub this out and see where we are there. Okay. There's plenty going on to do the solving now. So I've done the first part of, and the good news is, because there's a show of that, even if you're struggling with this bit, go on and use it. So I've now got to go on and solve the thing. I can say that all the n's on one side, I'm treating this as a whole expression. I'm going to be cross-dividing. I'll keep the 50 there, there's no reason why I can't. N minus 5,000. There, so it's the integral of that dn equals the integral of 1 dt. So this now becomes 50 ln mod n minus 5,000 and so it's bigger than 5,000, it's positive anyway, equals t plus c. So I can say that ln n minus 5,000 equals t over 50 plus my different constant, I'll come to that in a moment, the c's aren't the same, and then n minus 5,000 equals e to the t over 50 times e to the c as before, and if you remember I can write it as a e to the t over 50. So n equals 5,000 plus a e to the t over 50. Now they've given us an initial setup, that's to find a. So t equals 0, n equals 8,000, bit by bit, I've got 8,000 equals 5,000 plus a will equal 3,000. I'm using the initial conditions that I'm given there. And now I've got to solve it when n is 11,000. I've got 11,000 equals 5,000 plus 3,000 e to the t over 50. So minus it to get 6,000, divided by 3,000 to get 2, e to the t over 50, equals 2. So t over 50 equals ln 2, t equals 50 ln 2, or 2 to the power 50 equals, and then press button to get your answer there. So there's the show of that to do the setup, there's the separation of variables to actually get our equation, there's the initial conditions to find the constant of integration in there, and then there's using all that to solve an equation to find at the end there. Okay, so notice because I've got those two things there, I'm looking at the sentence, my dm by dt, what goes in minus what goes out. If I assumed that there's more going out than coming in, I would have had minus and then had these the other way around. It would have still ended up with exactly the same equation. So it didn't really matter. Let's have a look at the next one I've got here then. Water cools at a rate proportional to the difference between its temperature and surrounding temperature. This is known as Newton's law of cooling. Doesn't say so there, but it is. Boiling water is left in a room and cools to 90 degrees in 5 minutes. So that's a sneaky way of saying T is naught. You need to know that boiling water boils at 100 degrees. So that's going to be leading towards one of our constants. If the room temperature is 20 degrees Celsius, how long will the water take to cool to 60? So on notation, we tend to use the letter theta for our temperature. So theta naught is our initial temperature of 20. So let's have a look at the sentence then. Water cools at a rate. So the rate of cooling of theta minus, because it's cooling, don't forget, and it's proportional, so it's K, and then the difference between the temperature, what it is, minus the room temperature. So the idea is it's never going to go below the room temperature. That would be a bit weird. It's just left to cool. So that's our Newton's law of cooling. Let's look at it again. It's the rate of change, it's cooling, so there's a minus, it's proportional, so there's a constant, and it's the difference between the temperature and its surrounding room temperature. So it's one minus the other. Okay? And then we can go on and solve it. I'll need all these bits of information here, because I've got a K to find, a constant proportionality, I'll have a constant of integration, which is why I need two sets of figures initially. Okay? So, separate the variables then. Integral 1 over theta minus theta naught d theta equals minus k times the integral dt. So ln theta minus theta naught equals minus kt plus c. This is fairly standard now. Do the exponential, theta minus theta naught, I'll put that in later on, equals e to this, so e to the minus kt plus c, and as before, I've got this. So theta will equal theta naught 20 plus a e to the minus kt. And that's what it is in this situation here. Two sets of values because I've got two constants to find. So initially, t is naught, theta is 100, so I get 100 equals 20 plus a, so a equals 80. So I've got theta equals 20, my room temperature, plus 80 e to the minus kt. And I need this t is 5, theta is 90, so I've got 90 equals 20 plus 80 times e to the minus 5k, and this is going to help me find k now. So 70 over 80 is 7 over 8, e to the minus 5k equals 7 over 8. So k is going to be ln of that divided by minus 5. So let's see what I do. So I get ln 7 divided by 8, close brackets equals, and divide by minus 5 to get a positive there, 0.0267 dot dot dot. And then use that information to solve to find when theta's 60 degrees. So 60 equals 20 plus 80 e to the minus 0.02 whatever t. 40 over 8 is a half. So e to the minus kt for shorthand equals a half. So minus kt is ln of a half, or t is ln 2 of my constant. Since I've got it there, I can do ln 2 divided by my answer equals 25.95. Check my question. How long will it take? Rounds off to 26 minutes. There we go. So in that case there, step by step then, notice I turn the sentences to my differential equation, separate the variables and solve it, realise I've got 2 bits of information because I've got 2 constants to find. One's quite straightforward, one's a bit of a faff on, and then use that to go on and find something else later on. Very similar to the one before. And lastly, let's look at the last one. A colony of insects. Oh, great questions. Initially had a population of 100 and is growing at a rate of 50 insects per day. If the rate of growth at any time is proportional to the population size, so I'm letting p equal the population, how many insects will there be after 10 days? Okay, so t is 0, p is 100, and they give me that the rate is 50 at that instant there. What this is going to do with the sentence, it helped me find the constant of proportionality. And then I think this one's actually an easier question than the last 2 before. So let's look at the sentence then. Growing at a rate, so dp over dt equals k. Rate of growth is proportional to the population size, so kp. There we go, nice and straightforward. And I can use this information here. 50 equals k times 100, so k equals a half. So dp by dt equals p over 2. Nice and straightforward. And I can then go on and solve it, and I can use this information also to find what the constant of integration is. So let's have a look at it. So 1 over p dp equals a half dt, so ln p, always positive as population, we're never going to have a negative population, equals t over 2 plus c, p equals e to the t over 2 times e to the c. There we go on that. T is 0, p is 100, so a is 100. Nice and easy. And then I've got to find it when t is 10. So p equals 100 e to the t over 2 when t is 10 equals 100 e to the 5 and equals whatever it does. Let's have a look. Shift e to the power 5 equals quite a lot, 14,841. And don't forget, since it's a population, don't put decimals. And that's it then. So bit by bit, turn your sentence into a differential equation. Use the information. Notice I do the shorthand of all the information given. Realise what it's going to lead to there. In this case, find the 2 constants, one of proportionality, one of integration, and then go and answer the question at the end.